Okay, now let's take a look at paper 2 for Chongqing High School's paper. Okay, let's take a look at question A1. Okay, so for this question, we are given 4 different diagrams. Before we look at the question here, let's decipher what are these 4 different diagrams telling us. Okay, so for the first diagram A, okay, so diagram A, we see that there are positive particles as well as negative particles here. So what can this tell us? This can tell us that it is the ionic bonding. Why is that so? Because we know that in ionic bonding, there is a presence of cations as well as your anions. Now, let's take a look at diagram B. In diagram B, we see that there are positive ions here as well as negative charges around it. So what does this look like? This looks like the metallic bonding. So if you guys remember about metallic bonding is the forces of attraction between your positive metal ions as well as a inner sea of delocalized electrons. Okay, now for C here, what does C resembles? Okay, this C resembles the graphite. If you guys remember graphite is it has a giant molecular structure. Okay, so since it has a giant molecular structure, okay, it belongs to your graphite here. Another thing to take note of, what are all this? These here are your weak intermolecular forces of attraction. Where is this weak intermolecular forces of attraction found? It is found between the layers of carbon atoms. Okay, now for the last one, diagram D. Diagram D looks slightly different here. But what do you notice about this? There are 2 particles attached to one another. So what does this tell us? This tells us that this is a diatomic molecule. Remember about diatomic molecule means it contains 2 atoms that are chemically bonded together. So since this is a diatomic molecule, we know that this is a simple covalent compound. Okay, so let's take a look at the question now. Okay, so for the first question, which structure best describes aluminium chloride? Aluminium chloride is made up of metal as well as non-metal. So we know that this is an ionic compound. So ionic compound, which one would it be? It will be structure A here, diagram A. Okay, because diagram A tells us that it has a ionic bonding. Okay, structure B, which structure has the weakest forces of attraction? Now, when we talk about forces of attraction, based on all of this, ionic bonding as well as metallic bonding, they have strong electrostatic forces of attraction, right, between the oppositely charged particles. Okay, now, which one would it be? For question part B, it is D. Why is it D? Because in D here, what does it have? These are your simple covalent compounds, correct? So simple covalent compound, it has weak intermolecular forces of attraction between the molecules. Okay, so that is why the answer for part B is D. Okay, so which structure best represents strong oxidizing agent? Now, when we talk about strong oxidizing agent, what does it mean? It means itself, the substance, it is reduced. So what does reduce means? Reduce means that it has gained electrons. Okay, so when we are thinking about gaining of electrons, which of the groups we'll think about? We'll think about your halogens, which belongs to group 7. Okay, and another thing to take note about group 7, what kind of molecules do they form? They form diatomic molecules. Okay, therefore the answer would be D. Okay, so which structure here conducts electricity due to the movement of electrons? Let's take a look. The first structure, ionic bonding. Yes, ionic bonding can conduct electricity, but it is due to the movement of your mobile ions that act as charge carriers to allow electricity to be conducted. How about metallic bonding in metals? Your metals can conduct electricity due to the presence of your sea of delocalized electrons, correct? So structure B is able to conduct electricity due to the movement of electrons. Okay, how about C here? Graphite. Can graphite conduct electricity? Yes, it can. Why is that so? Because in graphite, one carbon atom is attached to only 3 other carbon atoms. So it means that one carbon here, it has a free valence electron that is not covalently bonded. So this free valence electron is able to move through the giant molecular structure and allow electricity to be conducted. Okay, so B and C, they are able to conduct electricity based on the movement of electrons. How about D? Simple covalent compounds. Always remember, simple covalent compounds, they cannot conduct electricity because there is no free moving ions nor is there any electrons. Okay, therefore the answer for D will be B and C. Okay, so which structure represents the material used as the anode during electroplating of aluminium? So we want to electroplate, we want to coat aluminium onto the can drinks. So whenever we think about electroplating, remember this one. Okay, C-O-N-A. So what does C mean? C refers to cathode, O refers to object, N refers to materials, okay, and A refers to the anode. Okay, so anode, we are talking about the material. So what material are we talking about? We are talking about aluminium. So since aluminium is a metal, we will know that it has metallic bonding, which is diagram B. Okay, now let's take a look at A2. Okay, so for A2, we have a chemist here who wants to isolate aluminium metal by using potassium as well as aluminium chloride. Okay, so they want you to write an equation here. So potassium reacts with aluminium chloride to form aluminium plus potassium chloride. Why is that so? This question here is based on the knowledge on your reactivity series. Okay, so let's write down Okay, so reactivity series, potassium as well as aluminium. Now, potassium is more reactive than aluminium. So potassium here, it is able to reduce aluminium from aluminium chloride to form potassium chloride plus aluminium. Okay, even though the question did not ask you to write a balanced chemical equation, it is always important for us to write a balanced chemical equation. Okay, so now part B. Explain in terms of electron transfer why the reaction is a redox reaction. So when we are talking about redox reaction, okay, we are talking about oxidation as well as reduction. Okay, so in terms of electron transfer, oxidation, we are talking about what? The loss of electrons. Okay, reduction, we are talking about the gain of electrons. Now, let's take a look at the equation given to us first. Okay, potassium to potassium chloride. Now, in potassium here is an atom, correct? But potassium chloride, it is K plus. What does this plus mean? Plus means there is a loss of electrons, correct? So, from potassium to potassium chloride, since there is a loss of electrons, it is oxidized. So, we say that potassium atom here, it loses electron to form potassium ion in potassium chloride. Therefore, your potassium here is oxidized. Okay, now let's look at aluminium chloride. Aluminium chloride to aluminium. Aluminium here is an atom. Aluminium here, aluminium chloride, this is Al, 3 plus. So what does 3 plus means again? It means there is a loss of 3 electrons, correct? So to form aluminium 3 plus to aluminium atom. So it means that aluminium 3 plus ion needs to gain 3 electrons to form your aluminium atom. Therefore, since it gains electrons, it is reduction. So we say that aluminium AlCl3 here, it is reduced because aluminium 3 plus, it gain electrons to form aluminium atom. Okay, so explain why he used, for part C, explain why he used the dangerous and expensive potassium to prepare aluminium rather than using copper. Why is that so? Because let's take a look at the reactivity series. Okay, if I use potassium, potassium is more reactive than aluminium. So as we said earlier, potassium will be able to reduce aluminium from aluminium chloride. But if I use copper, copper is less reactive than aluminium. So copper will not be able to reduce aluminium from aluminium chloride. Okay, so for part D, suggests why it is essential for this person here to keep it away from water. When we are talking about having a reactive metal such as potassium, we know that potassium here, it belongs to which group? It belongs to group 1, correct? Group 1, they are known as your alkali metals. So remember about alkali metals, what kind of reaction does it go through? It can react with water, correct? They are highly reactive in water to produce metal hydroxide as well as hydrogen gas. Okay, so since it is highly reactive in water, we will need to store it away from water here. Okay, and always remember for group 1 elements, okay, we must always store them in oil here to prevent them from reacting with water in the environment. Okay, so what do we say? Potassium will react with water to form potassium hydroxide and water and hydrogen gas, or you can say potassium will react vigorously with water, or you can also tell me that aluminium chloride here is soluble in water. Okay, now for part E, the diagram shows the energy level. So we want to talk about your, which chapter is this? This is on your energy change. Okay, so when we're talking about energy change, it can be exothermic or it can be endothermic. So based on this diagram that's being given here, it has already given us the reactants, the amount of energy in the reactants and the products. So since the amount of energy in reactants is greater than the products, we know that it is an exothermic reaction. Okay, so let's draw the energy profile diagram. Okay, so it will look something like this, correct? Okay, so we are supposed to label this. Where is your activation energy? Activation energy is here. And always remember, it has to be pointing upwards. Why is that so? Because activation energy is always a positive number. Now, we also need to find the delta H, which is our enthalpy change. So what is enthalpy change? It is a difference between difference in the total amount of energy between your products and your reactants, correct? So we are talking about the difference, so therefore it is here. Because this is a exothermic reaction. Always remember, exothermic reaction, delta H is always negative. So since it's a negative value, the arrow should be pointing downwards. Okay? So, explain how, okay, for question F, part 1. Explain how the diagram is exothermic. Okay, remember just now what we said. Since it is exothermic, it means that the amount of the total energy of the reactants, okay, will be greater than the amount of energy of your products. Or you can say the other way around, the energy of the products is less than, okay, it is less than the energy of the reactants. So in terms of bond breaking and bond forming, okay, why is it exothermic? Okay, so do you all remember the overall equation? Delta H, your enthalpy change in total is equals to delta H of bond breaking. Bond breaking occurs to your reactants minus away the enthalpy change that happens in your bond forming. So bond forming happens where? To your products. Okay, so in order to get a negative value, it means that my bond forming has to be greater as compared to my bond breaking. Okay, so the total energy absorbed to break bonds in aluminium chloride is less than the total energy given out to form your bonds in potassium chloride. Okay, so let's take a look at part G. Explain in terms of reacting particles, why is there an increase in the rate of reaction when I have higher temperature? So this question is talking about your rate of reaction. So what do we know when there is higher temperature? At higher temperature, what happens to the reacting particles? The reacting particles, it will gain kinetic energy. So since it gains kinetic energy, it will start to move faster. And another point to take note of, it also means that more of your reactant particles, it will possess energy equal to or greater than the activation energy that is required. So what will this cause? This will increase the frequency of effective collision, thus resulting in an increase in the rate of reaction. Okay, for part H. So in this question, they ask you, it is filled, the experiment is filled with inert argon. Okay, so when we think of argon, argon belongs to group 0, correct? A special name given to it, it is known as a noble gas. So what does inert means? Inert means it is unreactive. So using the electronic structure, okay, explain why argon can provide an inner atmosphere. Because what kind of electronic structure does argon have? It has a 288 structure, right? Electronic configuration. So what does this mean? It means that since it has a full valence electron shell, which is fully filled with electrons, okay, it will not be able to gain or lose any more electrons. Hence, it is unreactive. Okay, now let's take a look at question A3. So in this question, we want to use electrolysis to extract out our aluminium. But before that, okay, concentrated sodium hydroxide is used to dissolve aluminium oxide, okay, to separate it from the insoluble metal oxide impurities. So let's take a look for the first question, part A. Explain why concentrated sodium hydroxide is used to dissolve aluminium oxide. It is because aluminium oxide here, it is an amphoteric oxide. What does it mean by being an amphoteric oxide? It means that it can react with both acids and alkaline. Okay? It can react with both acids and alkaline to form salt and water. Therefore, since concentrated sodium hydroxide, this is an alkaline, correct? So it will be able to react with aluminium oxide to form your salt and water. Now, let's take a look at B. Okay, we want to write down the equation, okay, that happens at each of the electrode for your electrolysis of molten aluminium oxide. Now, aluminium oxide, what are the ions present inside? It will be Al3+, correct, in liquid state, as well as O2 minus, also in liquid state. Now, let's take a look at what is the half equation that is taking place at the anode. When we are talking about anode, which of the ions will be attracted to the anode? It will be the N ion. So, when we are talking about anode, it is also referring to oxidation. Okay, so oxidation, we mean that it is the loss of electrons. Okay, so who will be attracted to the anode here? It will be your oxide, your O2 minus. So O2 minus in liquid state here, it will give us oxygen plus 2E minus here, 2 electrons. Okay, now at the cathode. So the cathode, remember, cathode will attract the cations. Okay, so since it attracts the cations, what happens? It means that reduction will take place, and reduction, it is the gain of electrons. Okay, so with that, who will be attracted to the cathode? It will be your aluminium 3+. So if aluminium 3+ gains 3 electrons, it will form aluminium. Make sure that it is in liquid state here. Why is it in liquid state? Because this whole reaction here is taking place at a very high temperature. We need it to be at high temperature so that aluminium, your aluminium here will be at, so that your aluminium oxide will be at a molten state. Because aluminium oxide, this is an ionic compound, correct? In order for it to be at molten state, it requires high melting temperature. Okay, so this will result in aluminium being in liquid state instead of solid state. Now, let's take a look at the next one. Draw the dot and cross diagram for carbon dioxide. So what is the formula for carbon dioxide? It is CO2, correct? So for carbon, it is 2, 4. Oxygen, it is 2, 6. They want you to only show the valence electrons. Okay, so carbon, in order for carbon to achieve the noble gas configuration, it means that it still needs to gain 4 more electrons, correct? Where is it going to gain the 4 electrons? It's going to get it from oxygen. So how are we going to draw this? Okay, so always put the lone atom in the middle of the structure, and then we will have oxygen at the side here. Okay, so what happens? Because oxygen here needs how many more electrons? It needs 2 more electrons, right? So it means that your oxygen will share 2 electrons with carbon, and carbon will also share 2 electrons with oxygen. So how many electrons are left over behind for oxygen? It will be 4 more electrons. So similarly for this one, it will be the same. Okay, so this is the dot and cross diagram for carbon dioxide. So now, if I were to ask you, draw the structural formula for carbon dioxide, it will be C double bond it will look something like this. Okay, so what does this refer to? This refers to this part where it is a double, it shows a double covalent bond. So what does a double covalent bond means? Means there is a sharing of two pairs of electrons between the non-metal atoms. Okay, now suggest how carbon dioxide is formed from this electrolysis. Let's take a look here. Based on the half equation that's taking place at the anode and the cathode, oxygen is formed, am I right? Okay, we have oxygen that is formed as well as aluminium. So in order for carbon dioxide to be formed, it means that the oxygen here should react with something else. So who did it react with? The oxygen actually react with your graphite. What is graphite made up of? It is made up of carbon atoms, correct? So what happens here? How is carbon dioxide formed? The oxygen that is produced at the anode, okay, it burns and it will react with the graphite, okay, to form your carbon dioxide. Now, for question part E, state the substance left in extraction after all of the aluminium has been used up. It will be your concentrated sodium hydroxide. Why is that so? Because remember, the purpose of your concentrated sodium hydroxide, it is used to dissolve the aluminium oxide to separate it from the metal oxide impurities. So what is left over? It is only your concentrated sodium hydroxide. Now, explain why the substance stated in E would cause harm when it is exposed, released into the environment. Now, concentrated sodium hydroxide, this is an alkaline, or I can say that it is a strong alkaline. Okay, so since it is strong alkaline and it is also highly soluble in water, what will happen to it? When it actually flows off into the water body or into the lakes and seas, it will cause the pH of the water to increase, right? It will increase the pH of the water, so this will affect the pH of the water that the aquatic plants and animals are living in, therefore destroying the balance of the ecosystem. Okay, explain why the extraction of aluminium cannot be done using aqueous aluminium chloride. Now let's take a look at aqueous aluminium chloride. What are the ions present inside? It will be Al3 plus aqueous, Cl minus aqueous, H plus aqueous. Because aqueous? Because it is in aqueous state. Aqueous state means there is a presence of water. So another one that is present is also H plus, OH minus aqueous. So let's take a look at what happens at the cathode. Who will get discharged at the cathode here? Will it be Al3 plus or is it your H plus? In this case, instead of Al3 plus that is discharged, H plus is discharged. Why is that so? Because hydrogen is less reactive as compared to aluminium. Therefore, hydrogen will want to be discharged to produce your hydrogen gas. Okay, so let's see. In this case here, in the aqueous solution of your aluminium chloride, H plus, as I said earlier, H plus will be discharged over your aluminium 3 plus because H plus is less reactive than aluminium. Thus, it will give us hydrogen gas. Okay? Now, some of the drink cans here are made from iron electroplated with aluminium. So what does it mean? It means that on my aluminium, there is a layer, on my iron, okay, there is a layer of aluminium coated around it. So aluminium is more reactive than iron. So if the aluminium coating is being scratched, okay, would you expect the iron to start rusting? No. Why is that so? Because always remember, aluminium will corrode first as compared to aluminium will corrode preferentially over your iron because of the fact that aluminium is more reactive than iron. So it will react with probably your water as well as oxygen as compared to iron. Suggest a reason why aluminium is used for overhead cables. So overhead cables means they'll be hanging on top, right? Rather than copper. In order for us to want to hang it above us, it needs to be lighter. So your aluminium, why do we use aluminium over copper? Because aluminium is lighter as compared to copper. Okay, so aluminium used for making aircraft body are mixed with small amount of copper. So when aluminium mixed with copper, what do they form? They form an alloy. So when we are talking about an alloy, what is an alloy? It is a mixture of a pure metal with one or more other elements. Now, these elements that I'm talking about, they can be metals or they can be non-metals. Okay, so let's take a look. Let me draw out. If I have aluminium here, okay, so initially, the atoms of the ions, the positive cations of your aluminium, pure aluminium, it will look something like this, correct? You will see that the ions, they are arranged in a regular arrangement. Okay, so what will happen if a force is being applied? If a force is applied, the layers of ions, the layer of atoms will be able to slide over one another easily. So that is why pure metal or pure aluminium, they are usually malleable and ductile. So what is the purpose of us adding copper here? What will it cost? Okay, so take note, if I were to add copper, so for example, copper is of a bigger size, okay, what do you think happens? What do you think happens to the regular arrangement of your pure metal? It has been disrupted, right? So why is that so? Due to the different size of the elements of the different metals, this will disrupt the regular arrangement of the pure metal. Therefore, if a force is being applied, the layers of atoms will not be able to slide over one another. Okay, so let's take a look at the answer here. The different size of copper atoms, okay, it disrupts the orderly arrangement or the regular arrangement of your aluminium atoms. So therefore, when a force is being applied, it will be difficult for the layers of atoms to slide over one another. Okay, so just a reason other than the cost, why is it important to recycle aluminium? Now, aluminium, we know that it is a metal. What do we know about metals? Metals, they are all finite resources. Okay, so we want to, because they are finite resources, what does it mean? It means they are limited. There is a limited amount of them that is present right now. So in order for us to save it, we need to recycle aluminium so that our future generation are able to use it. Okay, now let's take a look at question A4. Okay, so for this question, we want you to describe the process of separating kerosene and petrol by fractional distillation. Okay, so how do we describe the steps? So the very first step, when we are talking about fractional distillation, heat is involved, right? So we will heat the crude oil. This crude oil contains the kerosene as well as your petrol, and we want to vaporize them into its individual fractions. Okay, so the second step, the longer chain kerosene, it will cool and condense before your petrol, okay, in the fractionating column and to be separated from the petrol. Now, always take note when we are talking about fractional distillation, those that are of a shorter chain hydrocarbons, okay, because that they are shorter chains, they will get distilled out first, okay, due to a lower boiling point as compared to those that are of a longer hydrocarbons. Okay, so kerosene is processed by cracking. Okay, so why is it important? Now, when we are talking about cracking, cracking is the breaking down of what? It's the breaking down of our long chain hydrocarbons. Okay, long chain hydrocarbons into three different compounds here. Okay, it can be broken down into your short chain alkanes. It can be broken down into short chain alkenes, as well as last one, hydrogen gas. Why do we want to break them down into shorter chain alkanes and alkenes? It is because all of these shorter chain alkanes and alkenes, they are of a higher demand. Okay, so that is the purpose of us wanting to break them down into shorter chain alkanes and shorter chain alkenes. Okay, and for the last part here, when one molecule of kerosene cracks, okay, it breaks up to form petrol as well as another product. Now, let's take a look what is the formula of kerosene. It is C12H20, C12H26. How about for petrol? Petrol, it is C8H18. Okay, so how do we find out the other product, the chemical formula of the other product. Okay, how did we get this value here? How did we get 4? We take 12 minus 8, which will give us 4. And how did we get 8 hydrogen? It is because 26 minus 18, which will give us 8. Okay, so that is why we get C4H8. Now, let's take a look at question A5 here. Hydrogen is an alternative, renewable, clean fuel that is used to generate electricity. Okay, so in this data given to us, we have petrol and we have hydrogen. Okay, so describe how electricity is generated in hydrogen fuel cell. Remember your hydrogen fuel cell. What are the reactants that are involved? It is your hydrogen gas plus oxygen to produce what? The end product of this will be water. Okay. Okay, so this is the equation here. So how is electricity produced? Because hydrogen reacts with oxygen to generate electricity directly. Now, let's take a look at the calculation. Calculate the energy output for 1 gram of each fuel. Okay, so they give you the mass of each fuel already. Okay, so in order for us to do this, let's take a look here. Okay, if you remember your mole calculation, in order to find mass, you need the mole, the MR or the AR. Okay, so we want each fuel, so we are talking about both petrol as well as hydrogen. So let's split up here. Now, I'll split it up. Let's talk about petrol first. Okay, so for petrol, how do we calculate? If we have 1 gram of petrol, okay, the first thing that we need to do is to calculate the number of moles of the petrol. Why? Because this has been given to us. Okay, so number of moles of petrol. So how do we calculate number of moles of petrol? We take the mass divided by the MR, which is 1 divided by, your MR will be for petrol is this one. So what would it be? It will be 114. Okay, so what is the answer for this? It will be 0.00877 mole. Okay, so what happens? Now that we have the number of moles, we must make use of the data that is given to us here. Let's take a look. What does this tell us? Okay, it means that 1 mole gives me 5450 kilojoule. Correct? Okay, negative sign because it's combustion here, which is an exothermic reaction. Okay, so if I have 0.00877 mole, how do I find this? Okay, it will take 0.00877 times 5450. So what answer do we get? Okay, it will be negative 47.8. So we'll get negative 47.8 kilojoule. Okay, now let's talk about hydrogen. So for hydrogen, the same thing. Okay, we first need to calculate the number of moles of hydrogen. So it will be 1 divided by the MR of hydrogen, which is 2, which will give us 0.5 mole. Okay, so same thing here. We are given the energy change of combustion here. So since 1 mole of hydrogen will give me negative 256 kilojoule. If I have 0.5 mole of hydrogen, it should give me 0.5 times negative 256, which will be negative 128 kilojoules. Okay, so we have both the answers. We have both the answers here already. Okay, so using the values that we have calculated and the information that's given to us, explain why petrol is preferred over hydrogen. Now, this is the answer, so let's take a look here. Okay, petrol is a liquid at room temperature as compared to hydrogen, which is a gas. Okay, so since it is a liquid, it means that it makes petrol much easier to store as compared to hydrogen. Because remember, hydrogen are very, very small molecules. So in order to get the same volume of hydrogen and petrol, it means that we will need a larger container, okay, to store all of our hydrogen. Okay, which comes to the second point here. Same mass of petrol and hydrogen, a larger volume of container is needed to be used to store our hydrogen. Okay, and for the same mole of petrol and hydrogen, petrol gives more energy as compared to hydrogen here. So now for this question, they say use the values that you have calculated and the information in the table. So it is very important for you to refer back to the answer that you have calculated earlier as well as the table. Okay, the information given in the table. So, but comparing the same mass of petrol and hydrogen, okay, hydrogen gives this amount, 2 times more energy than petrol. Explain why hydrogen is a clean fuel but petrol is not. Remember the equation when we are talking about the hydrogen. Okay, hydrogen reacts oxygen, it will form hydrogen, water, right? Okay, so what is being produced here? Water is being produced. Water is a non-pollutant. Okay, so when used as a fuel, hydrogen reacts oxygen to form harmless water. Okay, so rather than saying harmless water, you can also say it is a non-pollutant. Okay, so since it's a non-pollutant, it will not pollute the environment. While if petrol undergoes combustion, it will produce carbon dioxide gas. Carbon dioxide gas is a greenhouse gas which can lead to global warming. Okay, so what does global warming cause? It can cause the melting of your ice cap, therefore resulting in the flooding of your low-lying areas. Okay, now let's take a look at question A6. So hydrogen is an essential reactant in Haber process which will react with nitrogen. Okay, so if you remember your equation, hydrogen reacts with nitrogen to form your ammonia gas, which is a reversible reaction. So in order for us to produce ammonia gas can be used to produce a fertilizer. So what is the name of the fertilizer? It should be anything that contains your ammonium. Okay, so it can be ammonium nitrate, ammonium chloride, ammonium sulfate, or even ammonium carbonate. Because why? It will contain the ammonia gas. Okay, so now for the next part, we are supposed to calculate the NPK ratio of the fertilizer that we have named earlier. So for example, if I decide to write ammonium sulfate, the very first thing I need to do is calculate the MR of ammonium sulfate, which is equals to 132. Okay, so what do we do after that? We therefore need to write the correct NP and K ratio. Okay, and it has to be in whole numbers. So how are you going to do that? Okay, because we want to find the mass, the very first thing we are looking at N, right? So what is N here? There is 2 nitrogen. So 2 nitrogen will give us 28 over the total MR, which is 132, times 100%, which will give me 21. Okay, 21%. So you write down in whole numbers. So the ratio for this, because N is to P is to K, there is no P and K in the formula here. Okay, based on the formula that we have written down, there is no P and K. So in this case, it will be 21 is to 0 is to 0. Okay, now for this part, explain why liming of soil should never be done after the soil was treated with ammonium sulfate. So what is liming? Liming means we are using calcium hydroxide. What is calcium hydroxide? This is a alkaline. So what do you all remember about alkaline? Alkaline can react with acid to form salt and water, which is your neutralization reaction. Alkaline can also react with, okay, alkaline can react with ammonium, salt. To produce what? To produce salt, water, plus ammonia gas. Okay, so what is important, okay, for the plants when we add ammonium fertilizer? The plants wants to take in the nitrogen that is present in it. Okay, so by adding calcium hydroxide, it will react with the ammonium fertilizer, which is the ammonium salt that we are talking about here, to form ammonia gas. So since ammonia gas has been liberated already, it is a gas, right? So since this is a gas, it will escape into the air, and therefore it will reduce the amount of nitrogen content for the plants here. Okay, where the nitrogen content is the important part that we want in order for proper plant growth.